Hello everybody, welcome to this class on partial derivatives. Today we will be discussing what are partial derivatives, how to calculate the second order partial derivatives, how to calculate the relative extrema and absolute extrema. So while calculating the partial derivative of a function with respect to one variable, keep the other variable constant. For example, look at question 1. If z equal to 4x cubed y squared, find del z by del x and del z by del y. Now del z by del x will be partial derivative with respect to x of 4x cubed y squared. That will be, treat y as constant, so it will be 4y squared into 3x squared. That is partial derivative with respect to x. So that would be 12x squared y squared. Again, partial derivative of z with respect to y, del z by del y will be partial derivative with respect to y of 4x cubed y squared, keeping x constant. So that will be 4x cubed into 2y, that is 8x cubed y. Now what are second order partial derivatives? So d2f by del x del y will be del by del x del f by del y. d2f by del x squared will be del by del x del f by del x. So first you calculate del f by del x and then you take again partial derivative with respect to x. Similarly, d2f by del y del x. First take del f by del x and then take partial derivative with respect to y. So we'll do a question on this. Question 2. If z equal to x cubed y plus x squared y squared, find d2f by del y del x. That's the first part. So first calculate del f by del x, that would be 3x squared y plus 2xy squared, keeping y constant. Now calculate d2f by del y del x, so keep x constant. So you get 3x squared plus 4xy. What about del f by del y? Del f by del y would be x cubed plus 2x squared y, keeping x constant. And now d2f by del x del y, keeping y constant, it will be 3x squared plus 4xy. And note that from 1 and 2, d2f by del y del x equal to d2f by del x del y, and this is always true except near discontinuities. Now we come to the chain rule with multiple variables. So if f is a function of x and y, and x is a function of s and t, y is also a function of s and t, then del f by del s will be del f by del x into del x by del s plus partial derivative of f with respect to y into del y by del s. Likewise, partial derivative of f with respect to t will be del f by del x into partial derivative of f with x with respect to t plus del f by del y into del y by del t. What happens if f is a function of three variables x, y, z? Say x is a function of stu, y and z are also functions of stu. In that case, del f by del s will be del f by del x into del x by del s plus del f by del y into del y by del s plus del f by del z into del z by del s. Again, del f by del t will be del f by del x into del x by del t plus del f by del y into del y by del t plus del f by del z into del z by del t. Del f by del u will be del f by del x into del x by del u plus del f by del y into del y by del u plus del f by del z into del z by del u. Coming to the next question. So if z equal to x cubed y raised to 4, x equal to s cos t, y equal to s sin t. So x and y are functions of s and t. Find del z by del s. So del z by del s by our formula will be del z by del x into del x by del s plus del z by del y into del y by del s. Del z by del x, treat y as constant, so it will be 3x squared y raised to 4. Del x by del s, take t as constant, it will be cos t. Plus del z by del y, treat x as constant, so it will be 4x cubed y cubed. Del y by del s, keep t as constant, it will be sin t. Actually, derivative of cos t will be, keeping s as constant, it will be sin t. Now put x as s cos t and y as s sin t. So substituting and simplifying, you get del z by del s is 3s raised to 6 cos cube t sin raised to 4t plus 4s raised to 6 cos cube t sin raised to 4t. What about del z by del t? Again, by the formula, it's del z by del x into del x by del t plus del z by del y into del y by del t. Del z by del x keep y as constant. It will be 3x squared y raised to 4. Del x by del t will be treat s as constant minus s sin t. Del z by del y keep y as constant. It will be keep x as constant. It will be x cubed into 4y cubed, and del y by del t keeping s as constant will be s cos t. And now you just substitute for x equal to s cos t and y equal to s sin t, and you would get the answer. Now we come to extreme values for a function of two variables. So given a function fxy, first calculate del f by del x and del f by del y, equate both to 0, and these are the critical points which we call as x0, y0. And now you calculate d, which is d2f by del x squared into d2f by del y squared minus d2f by del x del y into d2f by del y del x. So if d greater than 0 and d2f by del x squared greater than 0 at x0, y0, then f has a local minima at x0, y0. So you have to check d and the second order derivative with respect to x. If d greater than 0 and d2f by del x squared less than 0 at x0, y0, then f has a local maxima at x0, y0. And if d less than 0, f has a saddle point at x0, y0. So coming to problems, find the relative extreme and saddle points of z equal to x squared minus 6x minus 8y plus y squared. So first calculate del z by del x, that is 2x minus 6. Del z by del y will be minus 8 plus 2y. Equate del z by del x to 0, so you get 2x minus 6 is 0, implies x equal to 3. Equate del z by del y to 0, so you get minus 8 plus 2y equal to 0 or y equal to 4. So your critical points are 3, 4. Now we take d2z by dx squared, this is 2. d2z by dy squared is also 2. d2z by del y del x will be 0. d2z by del x del y is also 0. So in this case d is d2z by del x squared into d2z by del y squared minus d2z by del x del y into d2z by del y del x. This will be just 4, which is greater than 0. And d2z by del x squared is greater than 0. So by our condition, f has a local minima at 3, 4. And what will be this minimum value? In z, you put x equal to 3 and y equal to 4, and you get minus 25. Now going one step further, the next question would be find the absolute extrema of the same function over the square, x lying between 0 and 5, y lying between 0 and 5. So when y is 0, in your equation z becomes x squared minus 6x. If you equate x squared minus 6x to 0, you get 0 and 6. So x is equal to 0, y equal to 0, and 6, 0 are the two critical 2 points here. When x is 0, z becomes minus 8y plus y squared. Again, if I were to substitute y squared minus 8y as 0, I get y equal to 0. So your critical points are 0, 0 and 0, 8. When y is 5, put y equal to 5 here, so z becomes x squared minus 6x minus 5. Factorizing, you get x equal to 5 and 1, so the points would be 5, 5 and 1, 5. When x is 5, you will get y as minus 5 minus 8y plus y squared. This has no real roots. So we will consider the points 0, 0 and 8, 0 and 0, 8. So z at 0, 0 is 0, z at 0, 8 is also 0. At 5, 5 and 1, 5, calculate z. Z at 5, 5 is minus 20, z at 1, 5 is also minus 20. Now take 0, 0 and 6, 0. Z at 6, 0 is 0, z at 0, 0 is also 0. And by our earlier problem, the absolute minimum is minus 24 at this critical point 3, 4. So comparing all this, the absolute minimum will be minus 25 at 3, 4, and the absolute maximum will be 0 at 3 points, 0, 0, 0, 8 and 6, 0. So thank you everyone. We have learned what are partial derivatives, how to calculate first order, second order partial derivatives, and how to calculate the relative extrema and the absolute extrema. Thank you.